Welcome back to HFWorks video series. In this short video, we shall discuss the design and simulation of a miniature multiband antenna for the Internet of Things. The Internet of Things needs antennas. The Internet of Things transforms everyday objects, enabling communication and interaction over the Internet. Enhances intelligence and interconnection of things, increasing convenience and efficiency. Antennas, such as WIP, PCB, or chip types, are central to IoT, enabling data transmission and reception. These devices optimize daily tasks, work processes, and offer control over various life aspects. The challenge of antenna design in the IoT space. Electromagnetic design challenges. Size complicates antenna optimization. Antenna engineering, balancing size and performance is complex. Historical difficulty. Achieving the perfect balance has been a decades-long nightmare. Miniaturization in IoT requires smaller antennas with high efficiency, gain, and quality. Size versus functionality, a critical hurdle in advancing antenna technology. A printed inverted FPCB antenna. Explore the design and simulation of a printed inverted F antenna specifically tailored for IoT devices operating across LoRa and GPS bands. The antenna is optimized for performance at 915 MHz, LoRa, 1.57 GHz, GPSL1, and 1.23 GHz, GPSL2, fitting within compact dimensions of 40 by 25 by 1 mm3. Engineered on a PCB using an FR4 dielectric substrate, characterized by a dielectric constant of 4.3 and a loss tangent of 0.025. Optimizing the strip length L4. Observations reveal a clear correlation between the strip length L4 and the antenna's resonant frequencies. Extending L4 causes a downward shift in both the first and second resonant frequencies. The optimal strip length of 21.5 mm marks a peak in antenna performance, balancing resonant frequencies for ideal operation. This specific length of L4 is crucial as it aligns the antenna design with the desired frequency response, highlighting the importance of dimensional accuracy in fine-tuning performance. Optimizing the slot length L1. Adjusting the slot length L1 impacts the antenna's frequency response, specifically causing the second resonant frequency to decrease while leaving the first unchanged, demonstrating selective influence on dual resonant behavior. The ideal slot length for optimized performance is identified at 11.5 mm, which effectively targets the desired resonance characteristics. This precise adjustment underscores the need for meticulous calibration to isolate and control specific resonant frequencies in antenna design. The gain pattern. The PCB antenna features a classical dipole-like radiation pattern, making it particularly suitable for IoT applications that demand stable connectivity. It provides consistent and reliable signal coverage, crucial for IoT devices operating in diverse environments. These attributes ensure efficient communication links, vital for the seamless operation of smart devices across various IoT systems. Conclusion. The development of a miniature multiband PCB antenna showcases the critical balance between size, performance, and efficiency required in modern IoT device design. Detailed simulations and optimizations reveal that antennas can maintain high efficiency and performance across diverse frequency bands, even within compact dimensions. This exploration advances our understanding of electromagnetic interactions and sets a precedent for future improvements, ensuring IoT devices evolve with reliable and precise connectivity solutions. All simulations of this miniature multiband antenna for IoT were conducted by HFWorks using its dedicated antenna simulation software package, HFWorks. Thank you for watching, and stay tuned for more videos.